Good morning, everyone. So I'm going to be talking about refactoring complex code bases because we've been doing this on the Firefox developer tools team. So I'm going to tell you a lot about what we've been doing. So my name is James Long. I naturally work on the developer tools for Mozilla. I blog at jlongster.com, and I am jlongster around the internet. So you can find me on Twitter if you have any questions or anything for me. We've been doing a lot of refactoring on the Firefox developer tools in the last 6 months to a year. I've been working specifically on the debugger, and the new debugger front end is essentially a complete rewrite. So all new code for the developer tools is written in React and Redux. So first, let's talk about why React. First of all, we really want to be able to say Firefox developer tools in React because that suffix is critical for getting any media attention, right? Also there's, if you Google search Firefox DevTools React, there's this weird thing called React Developer Tools that is #1. So that's a little awkward. Like, we should be the first Google result when you search this. So it's kind of weird. So for all these reasons, we're rewriting everything in React. No, but seriously, refactoring is a lot of work. So you really want to ask this question, is it worth it? And do your hardest to evaluate this in the best way possible. It doesn't bear fruit quickly. It's a lot of work. It makes things confusing for a lot of reasons for a short period of time, and it's just risky. But it is very easy to be tempted to write new code instead of fix up old code, right? It's very, very tempted to look around and look at the new libraries and frameworks and just be like, wow, my code could be so much simpler if I was doing it in there. So it's very tempted to ask this question, how hard could it be, right? I mean, look at all of this other code that we have that would just go away if we rewrote everything in this fancy new library. It's super easy to just gloss over all of the details of your current code. And so it's a very hard question to know if you should refactor. And usually, 6 months into a refactor, you hit this oh shit moment, which is just like, oh my gosh, this was a terrible idea. We haven't gotten anywhere new at all, and we're behind on features, and I haven't even reached parity with the old code bases at all. So age in a code base is a very critical aspect of the maturity of that code. It covers a lot of edge cases. You've already fleshed out the code. So you should really only refactor when you really, really know that you need to. Let's just watch this GIF again. It's just awesome. And actually, the end of this scene, he actually says, "Oh, I'm okay." So sometimes when you're refactoring, and it's a good thing, it turns out okay. So a few things that you can look for if you're trying to decide if you want to refactor. The first one I would say is there's just a high amount of churn. Are you spending 30% of your time putting out fires, or are you putting 80% of your time doing that? If you're spending 80% of your time just putting out fires, that's just really bad for not only time, but it's really bad for developer morale. And that's only going to lead to burnout. A second thing is there's severe architectural limitations. And so maybe you're hitting walls that you've just written yourself into a corner, and there are some big things that you want to try out, but you can't even prototype because the current code just isn't flexible enough. Another thing is that there's just too many things to fix. And so this is the one thing that we hit on the debugger specifically, is that not only did we not like the code, it was very difficult code to work with, but we just didn't even really like the design of it. So I spent 6 months or so trying to come up with like a good plan to migrate everything slowly. But really, there's so much to fix that it was actually just simpler and faster to do it wholesale. So let me show you a quick look at the new debugger. So if I have this code, this is a function with the debugger statement. This is very complex code. I'm going to pull up the Firefox developer tools, and you're looking at the new debugger right now. So we're still iterating on the design a little bit. This is a little bit early, but the sources are now a sources tree on the left. I can navigate it with the keys. And if I run this code, I'm going to click run. It should pause on that debugger statement, which it did. Now there are the stepping buttons in the upper left, and I can step over this code as you would expect. I have these tabs to manage multiple sources. And there's the call stack over here. So you can click on the different call stack frames and view that frame. And I can inspect the scopes. And so these are all natural things that you would expect in a debugger, right? There's nothing crazy here. But if you look at the old debugger, it's clear that we fixed a lot of problems. This is the old debugger that is currently in Firefox. The sources list is a simple list on the left with breakpoints scattered throughout it. It's not a tree. The call stack is a horizontal call stack at the top, which is kind of weird. And it's just very cluttered. There's blue highlighted things everywhere. I mean, how do you, like, what is selected right now? If you look at the current debugger, you can see that it's a lot more intuitive, as I already showed you. We have the tabs and the sources tree. The sources tree, I didn't really realize how much of an improvement that is when you're dealing with a large amount of sources. So I'm really happy to have that. So now, not only have we fixed current problems, are we already ahead of our current debugger, but the code is in a place where we can be super flexible. So maybe you want the ability to drag out the call stack and the frames and the scopes to actually have them in like a column view if you want to see all the information at once. We can easily do this now. We can prototype with this stuff, and maybe even expose this as to extensions or some sort of configurations options, or just have a lot more flexible UI. So we can iterate a lot more faster. Or maybe you're a minimalist and you just want the editor with source tabs and the stepping buttons, and then you have some sort of Vim-like command line bar to dig into the deeper data like scopes when it's paused at a breakpoint. I actually probably would prefer this, and so I might prototype this at some point. But the moral of the story is that we are way more flexible now. So previously, the code was a custom framework that was written around manual DOM manipulation. It used ad hoc events for the different widgets to communicate with each other. The code depended on global variables to be in scope. There was mutation everywhere, so components could just dig into each other and mutate the state and change basically anything that it wanted to. It was loaded with script tags, and so it was just extremely difficult to work with. And I spent a long time trying to clean this code up, but at a certain point, it's just easier to start it from fresh. So another problem is that it was written in Zool, which is this old, weird version of HTML. If you imagine HTML being forked back in 2004 with all this weird proprietary stuff put on top of it, that's Zool. It's a pain to work with. It's what the Firefox UI is built in right now, and we're currently migrating everything off of it, not just the DevTools, but Firefox itself. The code also depended on privilege APIs, so it assumed that it ran in the Firefox context. So you could only run it in the Firefox panel, right? So the new current code is written in React, so we have a much nicer declarative UI layer. We use Redux, which enforces certain asynchronous idioms, and the state is actually immutable, so you can't mutate it, which provides a lot of guarantees. And it's bundled with Webpack, so we have an actual modern browser loader now. So not only now are we writing tools for the web, but the tools are made of the web. And this gives us a lot more flexibility to dog food it in crazy ways, a lot easier for contributors like you all to come in and contribute to the code. So we're very excited about this. So just as a demo to prove what we can do now, previously you couldn't do this. I'm going to start the debugger. And I have another instance of Firefox already open. I'm going to make it listen on the debugger port. So it's listening. So now if I go to the debugger, local host 8000. So we have a very lightweight page which just shows the tabs of the Firefox instance that it's looking at. So I can click on the React to-do MVC example, and now I'm debugging this page. Let's see. Now I'm debugging this other page over here. So I can dig into the JavaScript sources. I can set a breakpoint. So let's see, when you toggle a source, it's going to hit that breakpoint. Toggle it, hits that breakpoint. I can step over it just like you would normally. And so I'm running the actual debugger, and it's actually talking the exact same way that it would as if the debugger was in the Firefox panel. Now, what's really nice about this is that I can just, if I pull up in the scopes, I can pull up in the current debugger to debug this debugger, right? And I can use all of our existing developer tools just like you would on a normal web page. And this is very neat because now, I have hot module reloading enabled. So now I can come in here and I can say, let's work with this object inspector a little bit. And when you're rendering an item, let's log the item that it renders. So now if I just console.log the item, save it, it's going to rebuild it hot module reload it and then patch it. So now I can see that it's rendering these 3 items in this console right now. All of this stuff is very typical for you all. This seems very boring to you. We haven't had this at all. The only way that we could debug our debugger is literally right here in the panel, which is really a pain because the only way that I could actually use the DevTools is to open this special thing called a browser toolbox, which debugs the Firefox browser. And OK, so that's not working. But so yeah, so that's exactly what I'm talking about, right? It breaks because it's not a normal developer code path, and so it's only used by Firefox developers. And so and the other big problem with it is that it's using the exact same version of the debugger that's in the Firefox panel. And so if I am working on my debugger and I break my debugger, I can't use the browser toolbox debugger to actually debug my debugger. Yeah, this is my daily life. So yes, so this is why developing this in modern web development technologies that doesn't depend on any Firefox proprietary APIs, it's been wonderful for us, and we're very excited about doing this more with other tools. So this is just the debugger, and there are other tools like the inspector, which are a lot more complicated than the debugger and already have a lot more code. So we're probably not going to we're actually not going to rewrite the inspector. The console is getting a lot of love too. It's sort of a refactoring. So each tool is sort of different. I'm not saying so. It's when I say wholesale, that just means a specific tool. I'm not even saying the entire developer tools are being rewritten. I mean, come on, that would be crazy. OK, let's close this. And so what I really like about this technology, about React and Redux, is that one way that I like to describe it is that it allows us to be transformers. It enforces boundaries throughout your application to make sure that you can pull out different pieces and reconstruct them in interesting ways. So we can literally have our app and then take it apart and put it back together in a totally different way. Another way to think about this is what kind of circles can you draw in your system? These are all pieces that you could take out and run in complete isolation. Now, this isn't about modules or small modules or things like that, because you can require a module, and it's just going to require in a bunch of other modules. What I'm talking about is when you pull in a module, that entire context of that module ideally should be separated enough to just run in a context that you may not have envisioned it for in the first place. So this is sort of subjective about where these circles should be drawn, but I always like to think of that the more circles you can draw, the better. So here, it's just a quick diagram. We have a protocol layer, we have the Redux actions, reducers, and selectors, and we have the React UI. And so this thing that people complain about Redux is boilerplate, but to me, it's actually just good architecture. I think it only becomes boilerplate when you misapply it to the wrong thing. I don't think you should put form state in Redux. I don't think you should do a lot of other stuff that people are putting in Redux. At that point, yes, it's just boilerplate. But at the core of this, for things like breakpoint state and sources state, which is used across the entire application, it's just it enforces good boundaries. And things like immutability make sure that you actually are never changing the state except in reducers. So all of these things are just good things. The actions enforce how we do asynchronous work, so you can only do asynchronous work in one place. The reducers enforce the state management, and then we have selectors as well, which allow us to change the app state over time, and the entire rest of the app doesn't care how the data structure is actually shaped. We also have this layer that's a protocol abstraction. This implements an abstract programmatic API. This allows us, so we support talking to Firefox, of course. We also have experimental Chrome and Node support as well. So we have things like this. These are just generic commands. You say, set a breakpoint at this location, or load the source text of this source. And it will translate these programmatic APIs to protocol requests. And depending on the actual backend or the protocol adapter that's loaded right now, it'll translate it to Firefox, or it could also translate it to Chrome. So we also have to translate the protocol data coming back. So if you have these location and breakpoint objects, Firefox and Chrome are going to return you very different data. And so we need to normalize it into this data so the rest of the UI can just use this data. And we actually specify them as types. And so this is really interesting because all of the protocol details, there's a lot of like weird things that go on in protocols, and a lot of that can be abstracted away. All right, so for example, now that we can talk Chrome, Node actually just landed Chrome protocol support, which is pretty cool, right? So I'm actually going to show you how to debug Node. So let's see. Got to do a few things. I started a project with the React Keystone project, which is it's a big project that allows you to start sites very quickly, and it has a lot of interesting things in there. So if I do node -- inspect and I start this site, this is going to start the Keystone site. So I should be able to go, let's see what in here, to localhost 3000. And so this is my Keystone site. This is a complicated engine. There's a lot of stuff on the back end going on here. Let's close that. So this is Node running. So there's a Keystone node server running, right? Let's see, I think I actually have to start something real fast. OK. Now, if I run my debugger, just npm start it again. Shoot. Oh, that's right. Sorry. Now, if I go over into my debugger after it builds, so the way that Node works is it gives you this WebSocket URL directly. And so what we did is the ability to just connect directly to Node. And so it says debugger attached down here, and it's fetching all of the sources. So there's a ton of sources with Node because of small modules. So it takes a little while for it to all load. But what I can do now is I can pull this out. And now I am connected to Node, debugging the Node application. This is still loading all of the sources. It takes a little while. All right, so now I'm debugging Node. So you can see these are all of the internal modules. And these are all of the Node modules. Let's go into the blog route. And let's set a breakpoint on the blog route. So this is backend code. This is Node code. So this is the blog URL. So if I refresh this page, which is the blog URL, it should break right here. And it does. And it breaks. And I can see the call stack. So I can select the different frames. It's just like you would normally. I can step over. So now I'm stepping through Node code. So we want to build out a good Node debugging story because we think that's critical for application development. So that's a Node. Yeah, that's cool. Thank you. Sorry, let me see. And so, as we were doing this, I was thinking, we have all this nice business logic in Redux. We have this nice protocol layer. None of this depends on the browser, right? So what would happen if we drew this circle around everything except the React UI layer? And so what you get is a CLI JavaScript debugger, which is something that I personally want as more of a geeky person because I just want to do things at the command line. So I'm going to show you this and see if it works. I do have to start this, I think. And so what I'm going to do is I'm going to go back to over here to the React To Do MVC demo. And I'm going to run my CLI debugger by going, let's close this node. Now I can just say, run my CLI debugger, which is experimental, but and I'm going to use RL wrap to wrap it into a readline instance, so I get readline support. Let's see. I need to check out actually a different branch. So now this should connect to Firefox. And so I get a prompt here, and it is evaluating. So it connected to this same one that I connected to before, which is the React To Do MVC demo. And I can prove this by saying alert. I can do alert over here, and so now it's alerting this page. Now, what's really nice about this is that this is native DevTools support. So I can refresh the page. I can even go to a different page if the Wi-Fi works. Of course it doesn't. I can still alert, though. I've already refreshed the page several times, right? Because it's just like if you had the DevTools panel open, when you're navigating to different pages, it doesn't break. That would be ridiculous. So not depending on script tags being loaded in the page or anything like that, it gives you this very powerful abstraction. And so, now that we have this, I was thinking like, well, we also have Node support, right? So it'd be pretty cool if I could just debug Node at the command line, because usually when you're doing Node development, you're at the command line. So let's pull open the Keystone example again. Let's open up the Node debugger. All right, so let's make sure that this actually started correctly. All right, cool. So this is serving. And so now, if I restart this and tell it to connect to Chrome, so now this actually connected to Chrome instance. And so this is my Node instance over here. Now I can do console.log. Now if I log that, it logged over a Node. Now what's neat is I added these little commands because obviously if you're at the CLI, you don't have a GUI to do anything. So if you say comma sources, it lists all of the sources. You can match sources, so this will list any of those sources that have the word route in it. So I'm going to look for my blog route, and so that's right here. So I'm going to take that identifier. Let's see, is it source or no? It's show. If I show the blog route, let's just take a look at it. So this is going to show the blog route. So I want to set a breakpoint on line 6. So I'm going to pull this up, and instead of saying show, I say break on that source on line 6. And so now when I navigate to the blog route, it breaks right there. Now I can also step through this just like I normally would, right? So yeah, that's pretty fun. And what's really nice about this is that this is also a console. So I'm literally if it's paused at a frame, it's going to evaluate stuff in that frame. So there's this view here. What is this view? Isn't there a request.headers on this or something? So now I can say, JSON stringify. We don't have great console support right now. Let's make that prettier. So those are the headers of my request right now. So that's interesting. So it's actually working, so I don't need to debug this. So that's cool. So that's no debugging at the CLI. But why don't we just take this one step further? Why would I want to be dealing with this terminal crap when I have this beautiful editor, Emacs, over here, right? Beautiful Emacs. What if I had the ability to run this in Emacs and integrate it with your editor? Because why should you have to be pulled out of your editor, which you spend all your Friday nights customizing? And so now I wrote this integration, right? This is just some 130 lines of Emacs Lisp code that integrates with my CLI debugger. So it's going to run it as a sub-process and know how to send it commands. So it evaluated, or it started it up right here. And then I'm going to go over to the Node instance. And so it says debugger attached, so I can console.log right here. So it's connected. Now, what's really neat about this is that I don't need to use these commands anymore. Well, actually, I do want to look for the blog route. So let's look for the blog route. But now I can just type Command O and open that directly. And then I can go up here and press F6 to set a breakpoint at line 6 like I did before. So now I can just set a breakpoint through the Emacs interface. Now, it should break on that. It doesn't look like it, but it did. Change to an arrow, right? Very, very interesting. And now if I press F8, I can step through this just like an Emacs. I can step into it, so I can look at what this on function does. No, that's not very interesting. Let's step back out. I meant to step into this one. Yeah, so now I'm into the render function. And so now I'm in my Emacs, just like I would normally want to be. I can change the code and save it and then just restart the server automatically. So this is where I want to be with no debugging. Visual Code is a very, very cool interface, and I love that it is embracing Node debugging as well, but all of you all use all sorts of other editors, and I feel like we want to bring you back into your editor. We don't need to force you to pull out of it just because you need something like no debugging support. So I thought that was pretty cool. So that is the CLI JavaScript debugger. Totally experimental. It's not even pushed anywhere, but hopefully it's something that I might work on over time. Thank you. So I want to talk about one technical aspect of our implementation, because it's something that we learned a lot about, and that's Immutable Gs. I love Immutable Gs. It has fantastic APIs for dealing with immutable data and updating immutable data. You can if you have like a deeply nested object, it provides great APIs for updating things in that object, then is performant because it shares the data structure. But the one thing that we've definitely run into is that it makes things very, very confusing in a different way, because you never know if you're dealing with an immutable object or not. And this comes up like, I mean, I'm not sure how other people get around this, but for me it comes up almost daily. Do I call breakpoint.getLocation or is it breakpoint.location? And it's confusing, especially because our actions receive normal JavaScript objects, and so you pass normal non-immutable locations into actions, but then they need to convert it to immutable for other various things. And so it's just very confusing. So you could try to use immutable everywhere, but when JavaScript does not have immutable values as the default, you're always going to be fighting the language. So this has been very confusing, and I'm not sure. The other thing is in our reducer, so we try to keep our Redux app state as completely immutable to try to mitigate some of those confusions. But the problem is that when we get massive objects back from the protocol, like we get this scopes object back when it pauses, it's this massive object, right? So it takes 130 milliseconds to convert that into an immutable object. And there's no reason for us to do that, because we're never going to even change it. This is just a static thing that we get from the protocol back that we just read from. We never actually change it. So this is just useless work. So the answer that we have is that we actually have started to mix mutable and immutable in our app state, so that now we can just do state.set. And I actually like that an immutable allows this flexibility to set whatever you want into it, because you can set basically anything into it. You do lose a little bit of the guarantees that the whole thing is not immutable, but it allows for these sorts of optimizations. But again, now it's sort of confusing. The scopes is not immutable, so in the UI layer, you have to remember that it's not immutable. And we can't do this anymore. So if you just have serialized your app state out somewhere, you can't load it in and just do an immutable from JS on it completely, because it's now mixed. So this was very confusing. And we actually talked a lot about giving up immutable because of this reason. We just felt like it was too confusing. But then when I looked at what it would be like to give up our immutable stuff, the reducers got super annoying. So we talked a lot about this. And what we eventually decided on is just to go ahead and do static typing. And so with Flow, Flow gives us the ability to declare what's immutable, what's not immutable, and provide great APIs for dealing with this. And if you forget that something is the wrong type, we actually see that super quickly now. So this has removed a lot of that. It introduces other pain as well, but it's still, I think it's a net win, because we also get to enforce a lot of the types across the rest of the system. So I actually looked into a lot of different things like Tcomb and trying to integrate other type systems with immutable, which would paper over some of the differences between non-immutable and immutable objects, but really they all sort of fall short. And Flow is super nice because now we can have a much more strong guarantees, not only with this immutable problem, but across our entire APIs. So we really want everything to be typed at this point. I'm a fan of static typing, and I like the fact that Flow doesn't force you to do that. So we have a couple modules which aren't typed, which are totally fine not to type. So this has been a big win for us as well. So I want to talk a little bit about just problems as well, because I've talked a lot about refactoring and how it's really hard, and how for us we've seen some big wins early on, and how it was clear that this was a good decision for us. But even though it was a great decision for us, in a lot of obvious ways, there is a cost. And during refactoring, it feels like this a lot of the time, because there's like two versions of the same library going on. Like one is the older one that is getting bug fixes, but then you have your newer one that's being worked on, but it's not getting those edge cases covered. And so a lot of people, it's just super frustrating. So a couple frustrations is that, first of all, really just new architectures and big decisions need to be accepted by the whole team. And this can be a very hard thing because a lot of people have a lot of different opinions. I found that it really exposes what different people's vision of what they want their product to be. And so you need to reconcile these big questions. And that's a lot of work. And it potentially can breed conflict. So if you're going through this, I would encourage you just to really listen to other people and try to respect their opinion. It's very hard to work on existing code if it's being refactored. As I said, usually there's like two versions of it. So right now, technically we have two debuggers. For a short amount of time, it's just going to have to be the case. It's just very confusing with a lot of things changing. But luckily, or hopefully, you see enough big wins early on that it's worth it, and you just push through it, and you get through it as fast as you can. And hopefully, you don't have an oh shit moment where you just wasted a whole year. And sometimes people think that starting a React app sort of feels like this. I think this is more of a problem with people who just don't know React or Redux at all, because it's harder to know where to start. And I think that's where people are misapplying Redux and a lot of stuff like that. I think people that had just started with React and just used React Component System, that's why I fell in love with React, is that it was just one library that I could take and use. But unfortunately, this sort of is a conception around that there's just so many tools going on. But there's a lot of work to fix this as well. But it can be hard to convince your team because they just feel like it's very complicated. So we are open source. We are at this GitHub URL. And so if you would love to contribute, we'd love to have you. And it's great that we're this modern web stack now, because all of you all could probably dig in there and start doing stuff really, really fast. So we have a lot of bugs. There's a lot of work that we have to do. So please come talk to me if you're interested in this. So that's all that I have. Thank you.